Good morning, good afternoon, or good evening. In this video, we're going to keep working on section 1-3 from our pre-calc book, more on functions and their graphs. This will be the second day, and we'll wrap up the examples here in this video. First, let's have a little warm-up from the last video when we were talking even and odd functions. Here's 4 functions. Pause the video, figure out if they're even or odd or neither, and then start it back up, see if you got the answers right. All right, number 1, even exponent, that's an even function. Number 2, odd exponent, there's an implied 1 there, so that's also an odd exponent. That makes it an odd function. Now we got some constants that come into the mix here. So number 3, even exponent, so it looks like an even function. And remember, constants do not throw off y-axis symmetry. So this is an even function. Number 4, odd exponent, but here the constant is going to slide you off your origin symmetry. So here we have a neither. It's not even, it's not odd, it's neither. Okay, in the last video we talked a little bit about piecewise functions. Here we're going to graph one. So our function f of x is x plus 2 if the x values are less than or equal to 1. And our function f of x is 4 if our x values are greater than 1. So the way I've always attacked these types of problems is, here we have the x value where we transition from one graph to the other. So at x is 1 is where we're going to jump between two different graphs. So what I could do here is I'm going to put a little dotted line, red dotted line here on x is 1. To the right of that dotted line, we're going to graph one of the functions, and to the left of that dotted line, we'll graph the other function. So let's start with the first piece here, x plus 2 if we are less than or equal to 1. So that means we are going to be going to the left of this red dotted line. And to graph the function x plus 2 or y equals x plus 2, just think back to good old slope-intercept. 2 is our y-intercept. I'm going to put a dot on 2. The slope in front of the variable x is an implied 1 or 1 over 1, so I'm going to rise 1 and run 1. So I am going to be right here on the dotted line. Now will I use an open or a closed circle? Let's go back to the inequality, less than or equal to. The or equal to tells me I'm going to color that in, and then I can just graph that line. Good enough. Now, once we pass this line at x equals 1, our x values are beyond 1, we jump to a different function, 4, or just y equals 4. Well, it's just a horizontal line. It's going to go through the y-axis at 4, but here we're actually not going to hit the y-axis because this graph doesn't start until we're here on the dotted line, and then we're going to head off to the right. Notice open circle because that inequality is strictly greater than, no or equal to part to it. Now to make the graph look even better, I can get rid of my dotted line. It shouldn't be there. I was just using it as a visual cue to know when to stop graphing one function and start graphing the other. And I think that's sort of the part of this great question I have hidden down in the corner. Whoa, there it is. Let me make this bigger. Somebody says, when I graph the function in example 4, here's what I got. Is my graph okay? So notice they graph the entire line here going through 2, but this is where we put our dotted line here at 1. So this blue part of the graph they should have erased. And then here to the left of this dotted line, they should have erased this part of the other graph. And then it would have looked like ours, which was very correct. Now, some piecewise functions are called step functions because their graphs form discontinuous steps. One such function is called the greatest integer function, symbolized by this, int, and then they have x in a set of parentheses. Or more commonly, you see this, it's kind of like double absolute, value bars. But sort of the end a little curved out like that. So it's kind of like double bars. But this is just the greatest integer function, or sometimes people just call it the step of x. And basically you're just rounding down. You always round down no matter what. Like here they have the greatest integer of 1 is 1. You round it down. What if it's 1.3? Round it down to 1. What if it's 1.5? Round it down to 1. What if it's 1.9? With this greatest integer function, we never round up. In this case, we always round down. So even 1.9 is round down to 1. And here's a couple others here. And let me point, yeah. The greatest integer of 2 is 2. 2.3, round it down to 2. 2.5, round it down to 2. 2.9, round it down to 2. I wish they'd point out the number one mistake I see in class with these is students have trouble when you get on the negative side of the number line. Like if you're at negative, if you're at negative 2.1, you're going to round it down to more negative. So this would round down to negative 3. If you were at negative 2.9, you also, it's just going to round more negative. You're going deeper negative, round it down to negative 3. So when we graph this, of course, this is why they call it a step function. It looks like a staircase. Remember, because we're always rounding down. If I'm up here at 2.9, I round it down to 2. If I'm at 2.8, I round it down to 2. So any number between 2.0 and 2.9999 gets rounded down to 2. So we have this flat step, open circle at the end. Then we jump up to the next step where we start with a closed circle. Because 3 rounds down to 3, and then 3.1, 3.2, all of them round down to 3. And we end that step on an open circle till we jump up to the next step. Blah, blah, blah. Okay. Now here we're getting a little bit, this is a baby step toward calculus, functions and the difference quotient. In an upcoming section 2.4, we'll study the average rate of change of a function. A ratio called the difference quotient plays an important role in understanding a rate at which a function changes. So the expression here, f of quantity x plus h minus f of x, all divided by h, when h is not 0, because we can't divide by 0, this is called the difference quotient of function f. And the name difference quotient, if we break it down, difference, if we find the difference between two numbers we subtract, we are subtracting in the numerator. And quotient just means it's going to look like a fraction, a numerator and the denominator. So our numerator is the difference, f of x plus h minus f of x. And then our denominator is always h, and h is always going to be non-zero. So here in example 5, they kind of baby step us. They give us function f of x, 2x squared minus x plus 3. They want us to find and simplify these expressions. First, they want us to find f of quantity x plus h. Once we find that in part A, we're going to put that in here for part B. So we're going to use the answer in part A as this part in part B. We'll subtract the original function and divide by h, and that will be that. So I'm just going to, whoa, why do I keep hitting that? I'm going to recopy the function down here. F of x is 2x squared minus x plus 3. Remember, those x's are just placeholders, so this could be the f of something equals 2 times that something squared minus that same something plus 3. And now for part A, we're going to plug in not just x, but x plus h, x plus h, x plus h, and then plus 3 at the end. Notice in the middle we got minus. The x plus h is in parenthesis. We will need to distribute that negative. That is a real common mistake. So I'm going to move over here. I'm going to need the room. So here's my equals. We've got 2. And now we got to FOIL this out. X plus h quantity squared will be the first thing squared plus 2 times the terms multiplied, 2xh, plus the last term squared, h squared. And let's not distribute that negative just yet. We'll do this all in one step because we've got to distribute the 2 here at the front. And let me erase and move some stuff up. Okay, so now easy stuff here, just distributive property. We'll distribute the 2, we'll distribute the negative. So 2x squared plus 4xh plus 2h squared minus x minus h plus 3. So there is part A, and we can't combine any terms. This is an apple, this is an orange, this is a pineapple, a papaya, and a beet. We can't combine anything there. But when we do part B, some of this will start to fall into place. So again, this answer for part A is now going to become, this is what we found here for part A. We're going to put that right here, and then we're going to subtract the original function f of x. So let me see here. I'm going to switch back to black ink. I'm going to recopy this because I got to write it a little bit smaller because we got to do this minus part after it. So I'm just going to take this stuff here in blue. Ooh, well, actually, I can just do this. I'm going to change it to a different color, and I can shrink it up just enough. There we go. Ha. So we're on part B. Here's the dividing line. Let's put our denominator h down there. And we've found this is our f of x plus h. So now we just got to do minus f of x. So I'm going to do minus, and we're going to subtract our original function as a quantity. So notice I got some grouping symbols here. I put a bracket. Now I'm just going to put this function in there. 2x squared minus x plus 3. That's a terrible 3. Let me fix it. That's a little better. Okay, so now the only thing we have left to do here is distribute this negative, and then we'll collect up any like terms we can find. So way back over here on the left, we've still got a 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Distribute the negative. I'll switch back to red ink. Minus 2x squared plus x minus 3. And don't forget, that's just a numerator. We do have a denominator underneath. It's h. All right, the only thing left to do is simplify and see if we have some stuff cancel out. I'm going to work my way back up from down here. So let's see, I'm going to switch to blue ink. The leading term 2x squared, well, here's a negative 2x squared. So those cancel out. And then we've got this minus x, and here's a plus x. Those are going to cancel out. And then here in red, the last thing is a minus 3. Here's a plus 3. Those are also going to cancel out. So I'm going to move back up here. Let's see what we're left with. We still have a 4xh plus a 2h squared minus h. I almost missed it in there. And this is all divided by h. Can we simplify anything else? Yes, we can. I'm going to show you two ways to look at this. First, in the numerator here, can we factor anything out? We can factor out an h. So if we pull an h out, we're left with 4x plus 2h to the first minus 1. And this is all divided by h. So now, get out of there. Now that I've factored this h out and we have one in the denominator, it's easier to see this cancellation that's going to occur. So what we're left with is 4x plus 2h minus 1. Okay, and again, this is a lead-in to something we'll see here in calculus, sort of at the start of the school year if you take that class next. All right. I guess it's time for you to get to work. Checkpoint 5. It's just like the last example we did. I guess I sort of have these in reverse order. Let's reverse that. Checkpoint 4. Graph the piecewise function. So you're moving from one graph to the other at -1. Here you just got a horizontal line. Here is a straight line. So graph each of those. Checkpoint 5. We've got a different function, -2x squared plus x plus 5. Just like the last example, first find the x plus h part, and then use that here in the numerator, subtract the original function, don't forget the grouping symbols, and simplify. Another word of warning on this, in our problem we did not have a negative in front of this, so when you FOIL out the x plus h quantity squared, you're going to distribute a -2. Mind your signs on there. So pause the video, try the problems, and then start it up and see if you got them right. Okay, well, I'm going to use dotted lines for my axes. I guess this will work. We are moving from one function to the other. I'll make this -1. So this will sort of be our, I'm going to use a solid line so I can just move it out of the way at the end. So to the left of this, less than or equal to -1, we want to graph 3. So here's 1, 2, 3. And because it's less than or equal to, I'm going to use a colored in circle, and we're headed off to the left. Now, if we go beyond -1 to the right, we want to graph this line x minus 2 or 1x minus 2. So my y-intercept will be down here at -2. And my slope is +1. So I go up 1 over 1, or I could go down 1 and back 1. And that should be an open circle because it's strictly greater than. And it opens up. There we go. And again, now that we've got the pieces of the piecewise function in the proper spot, I can get rid of that line. And there's our graph. Okay, checkpoint 5. Clean up here. All right. So first for part A, we want to take the original function, replacing the x's with quantity x plus h. So this is going to be -2 x plus h squared plus x plus h plus 5. So FOIL this out, and we'll save that -2 there. We'll distribute that in the next step. So there's an x squared plus 2xh plus h squared, and then plus x plus h plus 5. Distribute the -2, minus 2x squared minus 4xh minus 2h squared plus x plus h plus 5. So there's the answer to part A. We've evaluated the function at that quantity x plus h. And now we use this in the numerator of part B. Let me make that a little smaller. There we go. So here's what we have, the f of x plus h. Now we're going to do minus, let me switch to red ink, the original function f of x. When we subtract f of x, we're subtracting it as a quantity. So we're going to put a set of parentheses around there. Ooh, and I forgot the negative. Negative 2x squared plus x plus 5. And that's our numerator, and this is all over denominator h. So let's distribute that negative. Minus 2x squared minus 4xh minus 2h squared plus x plus h plus 5. Here we distribute. That'll turn to a plus 2x squared, a minus x, and a minus 5. Minus x minus 5. When you've done enough of these, they do get to be routine, and this cancellation should always occur. What I left up here in red, subtracting the original function, each of these terms should be canceled out. So here is our plus 2x squared. Here's a minus 2x squared to cancel it. Next up is this minus 1x. Here is a plus 1x. Those cancel. At the very end is a minus 5 constant. Here is a plus 5 to cancel it out. So if you're doing these right, that second function that you subtract, this minus f of x, should always be completely eliminated. Now let's see what we're left with here. Minus 4xh minus 2h squared plus h all over h. Now when we did the example, we factored an h out of the numerator and then canceled it once it was factored out. There is another way to do that when you feel more comfortable with these problems. I see an h in the denominator, and every term in the numerator also has an h, so I can cancel it out. But be careful, here's a squared over a first power, so this will only get knocked down 1 power to first. And this h is going to cancel, but it doesn't just disappear. There will be a placeholder 1 left there, just like when we factored it out in the example. So after we cancel the h's, our answer for part B is negative 4x minus 2h plus 1. Okay, I think that is the end. Extra practice if there's time. If you feel like here's a triple piecewise function to graph, you could pause the video and then try to graph this and then start it back up, see if you got it right. Okay, now this one, since we have 3 pieces, let me do this. If we're less than negative 4, so here's going to be one of our divider lines. And then we go from negative 4 to 0. So we'll also have one right here on the y-axis. And then greater than 0. So we're going to have one graph over here. We'll call this area. Whoa, I didn't want to do that. We'll have one graph over here in area 1. We'll have one graph in between these dotted lines, area 2. And then we'll have a third graph over here. I guess I can color code these. We'll start with red. If we are less than negative 4, notice or equal to 0 on there, just less than negative 4, we're at 0. So that would mean we are right on the x-axis. So the graph would look like that. In between negative 4 and 0, now at the negative 4 it's less than or equal to. On the other one it's just strictly less than. We just want negative x. So that is a slope or a line going through the origin that is sloped negative 1. So we will hit here, that'll be an open circle, and our slope is negative 1. So we're going to be coming down like this. Closed dot here because of that less than or equal to. Finally, if we are beyond 0, it is just a parabolic curve, x squared. So here, switched over to black ink. If we're starting at 0, and 0 is included, we're doing x squared. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared would be 9 just off the graph. So here is our parabolic curve, opening up. And there's our graph of the 3-piece piecewise function. The homework for this section is a worksheet. You can either download it from my website or got it off me in class. I'll see you in the next video.